Here we have a SAT math problem. Okay, let's go over the question. In the figure shown, point C is the center of both circles. The ratio of AB to CD is 6 to 5. If the area of the largest circle is 242, what is the area of the shaded region? Okay, now let's plan how to solve this problem. To get the area of the shaded region over here, what we have to do is we have to subtract the area of the smaller circle from the area of the larger circle. The area of the larger circle is given over here, that is 242. Now, our aim is to get the area of the smaller circle. Once we get the area of the smaller circle, it has to be subtracted from the area of the larger circle, that is from 242. The resulting area is the area of the shaded region. Okay, now let me consider the information we have over here. That is the ratio of AB to CD is 6 to 5. Here we have the ratio of the lengths of the two line segments AB and CD, that is 6 to 5. Okay, now let me write the stuff over here. That is the ratio of AB to CD equals to 6 to 5. Okay, here from the terms of the ratio, if I want to get the lengths of these two line segments, what I have to do is I have to multiply the terms of the ratio here by the same non-zero number, say x. That is the length of the line segment AB equals to, we have to multiply the first term of the ratio by the non-zero number x, that is 6x. Now to get the length of the line segment CD, we have to multiply the second term of the ratio by the same non-zero number x, then we get 5x. Okay, here I got the length of this line segment CD, that is 5x. Actually, this CD represents the radius of the smaller circle, and this BC also represents the radius of the smaller circle. Then the length of this line segment BC also the same 5x. And here we got the length of this line segment AB, that is 6x. Okay, now let me write over here. And the line segment AC over here represents the radius of the larger circle. Now to get the length of the line segment AC, that is the radius of the larger circle, we have to add this 6x and 5x, then I'm getting 11x. So here I got the radius of the larger circle, that is 11x. Okay, now let me get the ratio of the radii for two circles. That is, first let me write the radius of the larger circle, then radius of the smaller circle. That is equal to, we know that the radius of the larger circle is 11x. Let me write it. To the radius of the smaller circle is 5x. Okay, here both the terms are multiples of x. So we can divide both the terms by x to simplify this ratio. Here this x will cancel out, the same here. Then I'm getting 11 to 5. Okay, here I got the ratio of the radii of two circles, and that is 11 to 5. Okay, from the ratio of the radii of two circles, I'll be able to get the ratio of the areas of two circles. That is the area of the larger circle to area of the smaller circle. Now, to get the ratio of the areas of two circles, what I have to do is I have to square both the terms over here. When I square this one, I'm getting 11 square, and when I square this one, I'm getting 5 square. So this is a ratio of the areas of two circles. Okay, when I evaluate the value of this 11 square, it's 1 and 21, and when I evaluate the value of this one, I'm getting 25. Okay, here, from the terms of the ratio over here, if I want to get the areas of two circles, I have to multiply the terms by the same non-zero number, say y. That is, the area of a larger circle is equal to, we have to multiply the first term by the non-zero number y, then I'm getting 1 and 21 y. Now to get the area of the smaller circle, we have to multiply this term by the same non-zero number y, then I'm getting 25y. Okay, here I got the areas of two circles, that is the area of larger circle, and here we have the area of smaller circle. But already we know the area of the larger circle is given in the question, there is 242. So this 1 and 21y and this 242, both of them represent the same stuff, that is the area of the larger circle. So this 1 and 21y can be equated to this 242. Okay, let me do it. Okay, now to solve for y in this equation, I have to divide both sides of this equation by 1 and 21. When I divide both sides by 1 and 21, I am getting y equals to 2. Now to get the area of the smaller circle, we have to plug in this 2 for y over here. Okay, let me do it. Then I'm getting 25 times 2 equals to 50. Okay, here I got the area of the smaller circle. Okay, as I said earlier, to get the area of the shaded region, we have to subtract the area of the smaller circle from the area of the bigger circle. Okay, let me get the area of the shaded region. It is equal to area of the larger circle negative area of the smaller circle. We know that the area of the larger circle is 242 and area of the smaller circle is 50. Let me plug in 50 over here. Okay, when I simplify this one, I am getting 192. Okay, therefore the area of the shaded region is 192 square units.